we have to distribute. When you are multiplying that out, what would you do with your exponents? Do we add the exponents or multiply them? Add them, because the base is written each time. Alright, so 11/3 plus 4/5. What's that give me? 67/15. Plus that one will be 9p. Okay, 11/3 plus 19/5. What'd you guys get? Yep. Okay. Ugly exponents, but it doesn't matter. We just had to distribute, so just following our rules there. Alright, then these problems, the next four are like what we were doing yesterday, reducing radicals. So the sixth root, if there's a negative on the outside, just stays. Can you do the sixth root of 64? It's 2. Comes out evenly. Okay, so my A's, think about socks in the dryer. If you have 12 socks, we need groups of 6. How many can we form? With my B's, okay, I can only make one group, but yep, we have leftovers. We have 8, so we can make one group of 6, and there would be 2 remaining. Alright, number 3. So with fraction, we do the same thing, top and bottom. If I have 3 G's, how many groups of 2 can we make? 1, and there would be 1 G left over, so it stays under the radical. If I have 5 H's, how many groups of 2? And how many leftovers? On the denominator, 6 R's, so we can form 3 groups of 2. Alright, number 4, if we want to add or subtract with radicals, what do we have to have? They have to be like terms, so we have to have the same thing under the radical. Okay, so 2 radical 5, I can't do anything with that. It's just going to stay. The square root of 20 we could break into a 4 and a 5. The square root of 4 is 2, square root of 5. What do we do with the 3 that was already out there? Yep, you multiply those 2 together. So 2 times my 3 gives me a 6 radical 5. Okay, so 2 radical 45. So 45 we can break into 9 and 5. Square root of 9 is 3. That gives us a 6 radical 5. Adding like terms, you just add the coefficients. So 2 minus 6 plus 6 is 2 square root of 5. Alright, number 5. When I multiply these things, you multiply the numbers outside the radical together, so that would give me a 12. You multiply the numbers under the radical together, so 12 radical 25. Okay, the 2 is outside the radical, so I multiply it with the 4, so 8 radical 5. Inside, so that would be a negative 3 radical 5. And last, negative 1 times 2 is negative 2. So here, the square root of 25 is 5, so that means 12 times 5. These are like terms, that would be a 5 radical 5 minus 2. So 12 times 5 is 60, minus 2 gives me 58, plus 5 radical 5. Alright, the last problem, a factoring one. So if I'm asking you to factor, we are looking for the GCF. We always take out the smaller exponent. What's smaller, negative 5 or negative 3? Okay, so in the first term I took all of those out. In the second term, when you factor it out, it's like subtracting. So negative 3 minus negative 5, or negative 3 plus 5 would be 2. Right. And how can you always check your answer on that? If you distribute it back out, you should get your original problem back. Any questions on that one? Okay, so that's our review from yesterday and the day before. Let's pick back up and finish this section. So we were talking all about our radicals. We did reducing radicals yesterday, and we talked about adding and subtracting, multiplying. The last thing we need to talk about is when we have a fraction, rationalizing the denominator. In a fraction, it is never proper notation to leave a radical on the bottom. So final answer, we can never have a radical on the denominator. To get that off, we can't change the problem, so we are going to multiply the numerator and denominator, top and bottom of the fraction by the same thing. That's legal because if you're multiplying on top and bottom, you divide them, it's just multiplying by 1, so it doesn't actually change the problem. So let's say I gave you this problem. 1 divided by the square root of 3. Okay, I'm not asking you to give me a decimal or anything like that. I just want that radical off the bottom. So what we're going to do is just multiply by the square root of 3 on top and bottom. Okay, all we just did right there is multiply by 1, doesn't change anything. But the reason this works, 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? 3. So we made a perfect square on the denominator. That way the square root would drop out and we could simplify. If I said 5 over 4 square root of 2. And we have to get the radical off the bottom. We don't have to multiply by the entire denominator here. The 4 isn't the problem. The square root of 2 is our issue. So I'm still just going to multiply the square root of 2 on top and bottom. Now, if you did multiply 4 radical 2, that just means your answer will reduce at the end. So you're not going to get the wrong answer, it just adds a step. So 5 times the square root of 2 is just 5 radical 2. On the bottom, you multiply the things under the radicals together, so you get 4 square root of 4. What is the square root of 4? 2, so that means 4 times 2, which is 8. Now, if my denominator has more than one term, it becomes a little more complicated. I can't just multiply by a square root of 3. Because that would give me the square root of 9 minus the square root of 6, which doesn't totally cancel. Same thing if you multiply by the square root of 2, it'll cancel one of them, but not both. What do you guys think I could multiply by here? Anybody remember? Don't write this down yet. What if I just multiplied by the same thing? So don't copy this down yet, just watch for a second. My goal is to cancel the denominators. If I FOIL on the denominator, that gives me square root of 9 minus square root of 6 minus square root of 6 plus the square root of 4. Will that all cancel out? No, the square root of 9 is good, square root of 4 is good, those we can reduce, but the radical 6's don't. So how can I fix that so I won't have a radical 6? Yes, we need to do the conjugate, which is the same thing, but you change the middle sign. Okay, because if I multiply by that when I FOIL, we get radical 9 plus radical 6 minus radical 6. And then it would turn into a minus radical 4. Okay, so that's helpful because these terms now cancel. On the numerator, we distribute our square root of 2, so we get the square root of 6 plus the square root of 4. So now if we reduce, what is the square root of 4? 2. At the bottom, square root of 9 is 3, minus the square root of 4 is 2. Okay, 3 minus 2 is 1, so you could just drop that. You could say over 1, or just leave it off. Questions there? Let's try another one of those. Again, because I have two terms, we have something added or subtracted on the bottom. We can't just multiply the square root of 2. So what will I multiply by on this problem? So if we distribute, 3 times 5 is 15. 3 times the square root of 2 is just 3 radical 2. On the bottom, we have to FOIL. So we get 25 plus 5 radical 2 minus 5 radical 2 minus radical 4. Alright, 3 radical 2, we can't break that down, so the numerator just stays as is. Denominator, we have 25, the 5 radical 2's cancel, minus the square root of 4 is just 2. So we get 15 plus 3 radical 2 over 23. Always double check here that it can't be reduced. For instance, if I had 27 on the bottom, I could divide every term by 3, but here we cannot. So that's the final answer. Any questions on this? Do we need more like that? What if it's not a square root then? What if I give you a cube root? If I just multiply by the cube root of 3 on top and bottom, I get 4 cube root of 3 over the cube root of 9. Can I do the cube root of 9? No, so that didn't help me. If it's a cube root, we need to get a perfect cube on the bottom. So think about our perfect cubes, like 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. What could I multiply this one by? I want to get one of these numbers so that I could do the cube root. So, can I take 3 times something to get an 8? No. Can I take 3 times something to get 27? Yep. What would that something be? 9. So I'm going to multiply by the cube root of 9. Another way to think about it, we have 1 3. We need 3 of them, so you need 2 more 3s. 3 squared is 9. So we have 4 cube root of 9. On the bottom we have the cube root of 27, which is 3. This is the same thing as saying the 4th root of 3 over the 4th root of 5. We have to be able to get this 4th root of 5 off the bottom. So we have to think about what to multiply by. So a couple ways of thinking about it. You could think, well, I have 1 5, we need 4, so how many more do we need? 3. So you could say you need to multiply by 5 to the 3rd, if that makes sense to you. The other option is to write out your 4th powers if you don't know. Okay, 2 to the 4th is 16, 3 to the 4th, 81, 4 to the 4th, 256. 5 to the 4th is 625. And if you take 5 times 125, you get the 625. So a couple ways of thinking about it. All right, go ahead and simplify in here. 3 times 5 to the 3rd. What does that give me? Get 375. Are you guys just blind trust? If I write a number up here, it's got to be right. Nobody's double checking me at all. So sad. Okay, on the bottom, if I take 5 times 5 to the 3rd, I get 625. But what is the 4th root of 625? That's 5. So we get the 4th root of 375 over 5. Okay, so you have to be able to get radicals off the denominator, whether it's a square root, cube root, 4th root, any type of radical. Questions on those? What if I ask you to simplify this? All right. There's several things we need to do here. Can we leave a radical on the denominator? No, so we have to have the radical off the bottom. Can those radicals be reduced? Yes, so we have to reduce our radicals. If I'm trying to add, what do I have to have before I can add or subtract fractions? Common denominator. So we have a lot to do here. 3 different issues going on. You can really start anywhere, but why don't we start by reducing our radicals? Let's go ahead and break those down as much as we can so we can have nicer numbers. 12. So think back to yesterday. I need a perfect square that goes into 12. This gives me 2 over, the square root of 4 is 2 radical 3. Right, what about 27? 9 and 3. root of 9 is 3, radical 3. What do you notice in the first fraction? We can divide by 2. We drop those 2's out. So I have 1 over the square root of 3 minus 1 over 3 squared. Okay, we still have 2 things. We have to get the radical off the bottom. We have to get a common denominator. Which one do you want to do next? Common denominator. Okay. This one is 3 radical 3. What would I have to multiply this first one by so they match? So I have 3 over 3 radical 3 minus 1 over 3 radical 3. So my denominators match. We can subtract the top. 3 minus 1 is 2 over 3 radical 3. One last issue. How do I get the radical off the bottom? Times. It's only one term. There's no addition or subtraction. So all you have to multiply by is the square root of 3 here. No conjugate or anything needed. So that gives me 2 radical 3 over 3 radical 9. Square root of 9 is 3. 3 times 3 is none. All right. There was a lot there. We have questions. Last problem of the day. Yikes. That's a cube root. Sorry, it's a little blurry. We have a lot to do. We have to multiply on the top, we have to reduce radicals, we have to get radicals off the bottom. But let's go ahead and start with any simplifying first. Okay, I think getting the radical off the bottom is probably the hardest step, so let's reduce as much as we can before we get to that point. On the numerator, both of these are under the cube root, so we can go ahead and multiply them together. 8 times 2 is 16. M squared and m squared would make m to the 4th. And we have our m cubed. On the denominator, 32 m to the 4th cubed. What can I do next? We could divide. Both of those are under a cube root, so can we go ahead and divide those numbers? Absolutely. Let's do that. Okay. So when I do that, my coefficients, 16 and 32, if I divide those, it would leave me with 1/2. It's under a radical still, so I'm going to say the cube root. I have a 2 on the bottom. Okay, the top is just a 1, so I'll leave that off for a second. What happens with my m's? Those cancel. What happens with my n's? Okay, so all we really have is 1 over the cube root of 2. So now get our radical off the bottom. And you take 2 times something that is a perfect cube. So 2 times 2 would give us 4. That's perfect square. We get the cube root of 4 over the cube root of 8. And the cube root of 8 is 2. So cube root of 4 over 2. Any questions there. So yesterday I posted a handout on Google Classroom. That is due tomorrow. Tomorrow we will be reviewing and practicing all this stuff one more time, and then our quiz on Friday. Okay, it'll be a shorter quiz Friday, not anything real long. So, finish that handout, ask any questions, feel free to check your work.